Okay, for problem number 2, what is I? We only have here a single OP amp, and the routine is the same. First is you assign the different current directions. Okay, one current here, another dito, and the last one is this. Okay, and remember that you need to represent these currents. Your current here is A, this is your B, then we have the your C. After that is you identify the terminals. This is your inverting, and the second one is non-inverting terminals. Then you designate the voltages. That is B sub 1, the voltage here is B sub 2. By inspection, as you can see, B sub 1 is already present. What is B sub 1? B sub 1 is equivalent to 4 volts. And by the way we analyze your OP amps, whatever the voltage in your inverting is also the same as the voltage in your non-inverting terminal. So B sub 1 is the same as B sub 2, and that is 4 volts. Okay? So if this is your node 3, if you will try to apply your KCL at node 3, that will make a change, no? That will be a change. You can already obtain some of the currents there. KCL at node 3, summations of currents entering, there is only one, is equivalent to currents going up. Or this will be expressing now your B in terms of the voltage. The voltage in the output terminal is B sub O. So this is B sub O minus the voltage in node 3, which is B sub 2. Since there is no resistive element between this point, divided by the resistance in between, is equivalent to C, which is the voltage in node 3, that is B sub 2, minus the voltage at the ground, which is 0, all over 12 ohms. Okay? B sub 2 is equivalent to 4 volts. So B sub 0 minus 4 all over 6 is equivalent to 4 all over 12. This will cancel, 3. Okay? B sub 2 is also 4 volts. Okay? So that will be what? 24 over 12 is 2 plus 4. B sub 0 is 6 volts. Correct? Oh, yan. Okay? So how do we obtain now your I? You just have to go back into terminal 1. So KCL at 1, that is I is equivalent to A. Expressing your A in terms of the node voltage, that is B sub 1 minus B sub 0 all over 8 ohms. B sub 1 is already given, that is 4 volts. B sub 0 is 6 divided by 8. So that is 2 all over 8. Your I is 0.25. 0.25 amperes. Right? Okay? So this will be our next problem. Usually in terms of an IC, this is how your OP amp is supposedly and correctly connected. Should be connected in a cascaded manner. When you say cascaded, similar to resistors in series or in parallel. However, The term for electronic components like this is cascaded. In a similar way that your transistors are connected also, the term there that should be utilized is cascaded, either in series and in whatsoever manner. Let us try to mark your terminals. This is terminal 1, terminal 2, this is terminal 2, this is also your terminal 2. Okay? This is your 1 prime, we have there your 2 prime, then our terminal 2 prime. Okay, this is our ground connection. Let us identify your currents. Our current will be this one, A, B, C, okay, D, then our unknown current I. If you try to take a look, let us also try to represent our output voltages, that is your O. B sub O, we have here also your 0 prime, B sub O prime. So if we try to start by applying your KCL at node 1, KCL at node 1, currents going in is A, and current going out is B. And expressing your A and B in terms of the unknown voltages and known voltages, that will be 0 plus 2 sine T minus the voltage in node 1, okay, the voltage in node 2, and the voltage in node 1 prime, and the voltage in node 2 prime. 0 plus 2 sine T minus B sub 1 divided by 4 is equivalent to B, which is B sub 1 minus B sub 0 divided by 12. Since out of this your B sub 2 or your terminal 2 is grounded, that will make your B sub 2 equivalent to 0. And this is also equal to B sub 1. The same is true with the other OP amp. This is B sub 1 prime is the same as B sub 2 prime, and that is 0. Okay? So this is 0. 0. This will cancel with that. That is 3. So B sub O is negative 6 sine of T. Sine of T volts. Okay, you can check that in your handout. I think in your handout that is positive 6, mistakenly written as positive, but it should be negative 6 sine T. Okay, next, try to apply also your KCL at node 1 prime. KCL at node 1 prime. C is equivalent to D. Okay, expressing your C in terms of the unknown node voltage, this will be B sub O minus B sub 1 prime divided by 8 is equivalent to D, which is B sub 1 prime minus B sub 0 prime divided by 16. We already have your B sub O, that is negative 6 sine T. B sub 1 prime is equal to 0 minus 0 all over 8 is equivalent to 0 minus B sub 0 prime all over 16. So we can have here the value of B sub 0 prime. This will cancel to negative 12. Negative 12 sine T volts. Okay, will you try to check your manual or the handout that you have downloaded? I think I have written this one being positive, while in fact it should be negative. Okay, how do we find your I? You just have to apply your Ohm's law. So by Ohm's law, your I is equivalent to B sub 0 prime divided by 6 plus 12, or that is negative 12 sine of t all over 18. So your I is negative 0.667, or approximately 2/3 amperes. Okay? These are just a few of the examples under OP app. You can find lots of problems concerning an OP app. Okay? This is already problem number 3. If you have any questions in any of the problems that you have in the handout or in our discussion today, feel free to give me a message and I will try as much as possible to answer your queries. Okay? Remember, there are only 2 things that you need to utilize in order to analyze an op-amp problem like this. Number 1 is, always assume that the input currents are approximately equivalent to 0. Second, the voltage at the inverting and non-inverting terminal, regardless of value, are always the same. Okay? Itong dalawa lang na to. And the rest is your knowledge and your ability to analyze the problems applying the basic laws as well as the networks and theorems that we have finished previously, particularly KCL and KVL, loop and nodal. Okay?